Well, it's official. We're going to work on NLBA or equivalent smart battery analyzer and reset. We'll see about that. But first, let me give you a little overview of what we're working on and problems that we need to solve. So this is what you would recognize as a smart battery. What makes it smart? The formal specification for smart batteries came about in the 90s, early 90s. The idea behind it is that instead of having a battery that only has lithium cell or multiple cells, and we have to charge it, discharge it, and basically take care of it, instead, let's have all the electronics that monitor the battery, monitors charging, locks the battery in case of any failures. Let's put it on the actual battery. That way, we can swap the battery from one device to another device. And even if the voltage rating is different or charging rating is different, once we connect it to the device will read all that information. What should be the charging current, charging voltage, obviously, how many cells are inside, what's the say health level of those cells, how many cycles did the battery go through, and read the status whether it is locked or not. We'll get to the lock in a second, but first let's consider how it actually works. It's actually relatively simple. The chip on board over here in the battery is capable of communicating with the host device over an SM bus. SM bus is essentially I2C bus with a few minute differences, so it's not necessarily the same. But for the most part, if you get any microcontroller like Arduino or something like that, say ESP32, and just connect I2C to the SM bus on the battery and iterate or scan for the devices connected to I2C, the battery will show up. In addition, you can read certain registers from the memory of that chip. Now, reading the data is unprotected on these. So as soon as you connect to the battery as this I2C device, you can read the voltage, you can read specifications, perhaps a manufacturer, maximum charging current, charging voltage, the nominal voltage of the battery, number of cells, and all that stuff. All that is specified in the smart battery specifications. So let's take a look at it. Here we have a document from '98. This isn't very official, but essentially, if you go through documentation, all these registers will match. So what we can do is read, say we want to read a voltage, right? That's register 9. So what I have here is a Arduino Uno. There's a simple script that is uploaded, or firmware that is uploaded to the Uno, which basically initiates a I2C communication with whatever is connected to these wires. And it communicates with this software over here just to relay the data. It's on COM4, so if we connect, we are connected. We see design voltage 0 and device status and all that because the battery is not connected, right? Nothing on the other side. But just to show you how we would read a battery voltage. So again, we go to specification and we want to read the register 9. This is read only, obviously, we can't override that. And we read in millivolts. So either this is going to be word, most likely this is going to be word. So register 9, we want to read it as word, right? We received FFFF. Because nothing is actually connected. The device on the other side is not responding. But we're ignoring that. It's all 256, basically. You could read it as block, right? And in some cases, this is going to be a block. This is essentially a random data right now. And that's our voltage. So that's how we communicate with the device, and that's how we read specifications. Now, oftentimes what you need is you want to read the status, and we should have a status here somewhere. Battery status. It should be under register 16, and it's bit flags. So that is what would tell you whether the battery is locked or not. So if we read 16 as word, well, data is going to be all Fs because nothing is connected, obviously. I assume this would be all zeros if the battery is not locked, and some of the bits would be high, indicating some failures. Now, as you can see, I'm not connecting the battery because this battery is fake. It is detected as an I2C device, but it doesn't respond to anything here. It's basically a fake battery. This one is real, but I broke it. So essentially, I have nothing to show you physically how to communicate, but just take my word for it. Now, this can be done with a simple Python script, or as I said, in Arduino, you can, or those Raspberry Pi microcontrollers, you can code in Python for them, which is probably a lot easier than doing C. But it's a matter of preference. In my case, I prefer C, but I understand Python is a lot easier to operate. Now, as far as I understand, the majority of those applications, they allow you to read the data for free. Like, I think NLBA one is, you can use it after purchasing, obviously. You can use it without a subscription, but just for reading the data, which is already a pretty useful device because you can confirm whether the battery is locked or not. You can check stuff like whether the cells are evenly charged and stuff like that. But to unlock the device, to unlock the battery, you need to pay. And from what I heard, that operation is being done on the server, not within the application. So the application reads the challenge from the battery and sends it to the server, and server sends you back the solution, and that unseals the battery. Once you unseal the battery, you can write to registers that are writable. Without unsealing it, you have only read-only. You only have read access, not the write access. And that is the main reason we are actually working on this device. Some people either figured out the solution or essentially acquired the solution from somewhere, probably fell off the truck, and they keep it as a secret, obviously, and charge you a lot of money a month or a year or what have you to have access to these. Now, I've been asked why am I working on my YouTube automation tool that you can see in the background over there instead of NLBA. The reason is simple. I need my automation tools for eBay, autoresponders. In some cases, the feature that I'm working on right now is to send a message to everybody with pending order, unfulfilled order, that matches criteria. Like, I have a lot of orders for Flux. I would like to send everybody a message that, sorry for the delay. There's, been problems, but I'll fulfill your order as soon as I can. I also am working on a feature where I want the system to automatically bump the quantity on my listings if it goes too low, because you cannot renew the listing. You can only increase the quantity, which means you have to do a new listing, so you lose all that history and reviews and all of that from the previous listing and stuff like that. I just need it. For NLBA, fellas, the batteries are not very expensive and they are available. So the only use for me would be just to confirm that the battery is indeed locked, because I don't want to buy a new battery just to replace it and confirm that the battery was good all along. In many cases, you can, especially on laptops, you can start an application that will read that information. It's not a direct access to SMBus, because system usually doesn't have direct access to SM bus, but it does retrieve that information through either a chipset, BIOS, EC chip, I'm not sure. But it's capable of retrieving that information. And it will tell you whether the battery is locked or not. But sometimes you don't have access to that. Some laptops will not. And sometimes you only have a battery. You don't have the laptop that it goes into. Perhaps you do battery repair and you specialize in that. Which means you would like to connect to the battery. Also, you would like to check if it's charging, discharging, and all that kind of stuff. Now, these are two separate problems. We're going to come back to the charging and discharging. At the moment, all we want to do is just read the specification. And as you can see, it's really easy. It doesn't require any specialized tools or anything like that. But we also would like to do unlocking. Now, first of all, we need to understand why the battery locked. Why did it lock itself? It's very important for you to appreciate that this is a lithium battery. Lithium batteries are highly reactive and very dangerous if you don't appreciate them or don't understand how to handle them. Once this battery catches on fire, the only way to put it out is to bury it in sand. So there are special stations that you have. If this starts foaming up, basically the desk drops, the battery drops in the sand, and a whole bunch of sand is poured on top of it. That's the only way to do it. Otherwise, it's going to keep burning because it's self-fueling. It doesn't even need that much oxygen because it's self-oxidizing, and it's very reactive. You can probably find some videos on YouTube, people dropping a little bit of lithium into a beaker filled with water. The reaction is so violent that the beaker explodes. So be very careful. For that reason, when the battery locks up, that means there's something wrong with the battery. So if you just unlock it and give it back to the customer, that's a big liability. What if the computer explodes or catches on fire? This is pretty big battery. Cell phones, not so much. The battery is relatively slow, but it can still give you a lot of issues. But these large batteries, and this is not even the largest one, they store a lot of energy, and it doesn't matter if it is charged or discharged. Once the lithium starts reacting, there's no stopping it. You can sometimes see those Teslas on fire, and there's nothing the firemen can do. They can only spray around it to keep the area cool, and that's pretty much it, because you can't put the fire out with water or anything. You would have to have a dump truck with sand and just drop that sand on top of the car. That would help. But it'll still, underneath that sand, it'll still be reacting. It's extremely reactive, extremely dangerous stuff. For that reason, developing a tool that just allows you to reset the battery, perhaps without understanding of the risks, is very risky. In my view, it's a liability. You shouldn't be able to do that. For that reason, the manufacturers of the batteries have a way of preventing you from resetting them. Now, in my last rant, I mentioned that to unlock the battery, you need to provide a key that is 2 bytes long, and with modern computing, that is few minutes to maybe couple hours to crack that code. That was not true. Unfortunately, what I did, my analysis was just too shallow, and I guess I just spoke too soon without actually looking into it. I just kind of skimmed the documentation and stuff, and that's what I figured. But that's not how it works. The way it works, and that's why Tony was talking about the algorithms that someone started a company selling the application to reset the batteries, but he stole the algorithms from the company he worked for, something like that, I don't care. What did he mean by the algorithm? Well, if you want to unseal the battery, I don't remember which register it is, but you write to the register, the chip, the onboard chip, usually a BQ chip or something similar, it responds with what we refer to as a challenge. Now, if you're familiar with authentication and authorization, delegation, you're familiar with challenge tokens and stuff like that. But in this case, this is a lot simpler. So the battery sends you 2 bytes, 16 bits. And now on those 2 bytes, you need to perform an operation, that's the algorithm, and you send an answer. So essentially, it sends you that's why it's called challenge. It sends you a problem to solve, and you need to solve that problem and send the solution back to the battery. If the solution is correct, the battery will unseal. If the solution is not correct, you get access denied. Which means you can't easily brute force it because every time the battery sends you a challenge, it's a different challenge. So you can't just iterate over all combination, which is roughly 70,000. It's not a lot, but every time it is different. So the battery can send you a challenge or the combination that is one of 70,000, and you have to respond with the proper response that is one of the 70,000, and actually the number of combinations is a lot higher. So let's consider a simple example. The battery sends you 2 numbers, right? 2 bytes, and say 2 and 3. And the answer is 5, right? So if the battery sends you 2 and 3, you have to send 5. So naturally, you would think that, okay, we just need to add those 2 numbers together, right? But then the battery sends you 5 and 5, and you send back 10, and it's wrong. Because the actual algorithm was, say, the floored average of 2 numbers. So say 2 and 3, so floored, that would be 2 and plus 3, right? So it's always an average plus 3, right? So it works. There are more than one answer to this challenge, right? There are many algorithms that will satisfy that 2 and 3 will give you an answer of 5. So that's relatively complex, or at least it seems. Because with a simple example of 2 and 3, that's easy, but the operations you can run on these can be not only arithmetical, they can be bitwise operations. So, if you consider a number 2 in binary and you do a bit shift to the left, then you're essentially multiplying by 2. If you do bit shift to the right, you're dividing by 2, right? That's a simple hack for improving efficiency when you do arithmetical operations on, or arithmetic operations on the integers. And in some cases, if these are floating point numbers, you can still do the approximation, which improves the efficiency dramatically. If you're interested, check the fast inverse square root algorithm. It was popularized by John Carmack, but he's actually not the author of it. He knew that number from someone else. It's a approximation, but it's so efficient that it doesn't really matter. And it was for reflections and lighting and stuff like that, so it doesn't have to be exactly precise. So how are we going to solve that problem? Are we going to steal from the company the algorithms? No, of course not. That wouldn't be fair, and where's the fun in that? Second option, brute forcing. How does one brute force a challenge token? Let's get a simple calculator and let's draw some numbers. So first we initiate unseal. The device responds with 2 bytes, and we need to provide 2 bytes back. Instead of trying to break the algorithm or assume that, because there are a few typical ways they do it, and you can kind of create a list of possibilities and just check all of them. One of them might work. But even if it does work, you don't know if the algorithm was correct or you were just lucky. So you have to repeat it 3 times to make sure that the algorithm is actually correct. But there is no limitation on how those algorithms would work. As I said, it could be as simple as adding them together. It could be as simple as adding them together and running XOR. It could be more complex, adding them together, running XOR, bit shifting to the left and adding 3. Then it could be even more complex, all of the above plus dividing by 2 and running another XOR on it. It's not that easy to figure out because it's not like there's a list of all possibilities. Possibilities are essentially endless. Whatever the manufacturer wants to do, they'll do it. And it can be very random. So let's send a request for unseal, receive 2 bytes, and just send a random 2 bytes back. Now that operation, let's say it takes, SMBus is not very fast, but it's not super slow either. I don't remember, was it 250 kilohertz? Well, we'll run the number. We'll run the number later to kind of estimate the speed we would be able to do that. But for now, let's assume that we can do that 100 times a second. I don't suppose the chip actually has some throttling features to just kind of slow us down to prevent brute force attacking. Mainly because I think anyone who designs a security feature like that just relies on the secrecy of the algorithm. When we send random bytes back to the battery, we have roughly 1 in 70,000 chance that we got the correct answer. Which means, theoretically, after 70,000 tries, we should get at least 1 hit. Now we're talking about probability over here, so if we try 70,000 times, we might get 5 hits or we might get 0 hits. Both are possible. It's a probability. So say we have 70,000 requests and we do it 10 per second. So let's divide it by 10, that's seconds. Let's divide it by 60, that's minutes. And let's divide it by 60, that's hours. So we have roughly 2 hours to run 70,000 combinations. In those, we hope to get at least 1 hit. Now, once we got 1 hit, what does it mean? It means nothing yet, because we have 2 numbers and we have the answer, right? But we still don't know the algorithm. Again, going back to the previous example with 2 and 3, you can devise multiple different algorithms to match the solution to the challenge. I would think that we need at least 5 hits to have a good chance of breaking the algorithm. So this times 5, we have roughly 10 hours. That's assuming we get 1 hit per 70,000 tries. Now again, after 70,000 tries, we might get 0 hits. After 500,000 tries, we might get zero hits. It's the way it works. But you do it only once per a kind of battery. Let's say that this model is 69KF2, right? And if we, after say 24 hours, let's say it takes 24 hours to break the algorithm on this one, then you have algorithm for this particular battery. Then you have to do the same for another battery. And that's how the database would grow. Once we're in the position where we have 5 kinds of challenges and 5 answers to those challenges, now we can start brute forcing the algorithm. That is kind of a semi-random because you have to make an educated guess, right? So first, you have to find an algorithm that would fit all those 5 examples, right? It's kind of like breaking Enigma. Enigma had a feature where one letter would never encode to itself. So if you get the encoded message and you make an educated guess that it's a weather report, you can write weather report and just align it with the text. And if none of the letters are matching, that's very likely that that's what the message says. If any of the letters are matching, A encoded to A, it's not correct. That was actually a core feature of Enigma that allowed allies to break the code. It's actually Polish engineers that broke Enigma. And they, after Germans invaded, or Nazis, sorry, all that work was given to the Bletchley Park, and they did the rest. And in all fairness, the encryption that Polish engineers or mathematicians broke, it was a lot simpler than later into the war, especially Kriegsmarine. They had the most sophisticated way of encrypting. Anyways, these are just rough numbers, right? It might work, it might not work. In case of some batteries, we might be able to crack the code in 2 days, 3 days. In other cases, we might get lucky and just crack it in a few hours. And in other cases, we might be cracking for weeks and not get a hit. It's absolutely possible. There's a lot of luck that goes into it, and you have to make some educated guesses. So it's not something that can be easily brute forced. But that is essentially the way we're going to break the battery. Well, I want to call it security, but it's not really a security. This is basically just safety feature. For that reason, once we get the application up and running and we start actually delivering it to the other technicians, there will be a fail-safe and a lot of protection. So if you are trying to unlock the battery that has, I don't know, uneven charge, or one of the cells is completely dead or anything like that, the unlock feature will not work. And similar, basically some safety features, because we don't want you to unlock batteries that are plainly broken. It locked for a reason. There was a reason to lock, for the battery to lock up. Now, I know some of you guys are interested in that application and even would like to support the development of it. At the moment, it's just 2 people on this project. It's just me and Tony from Northwest Repair, the GPU repair expert. There's going to be a lot of testing that needs to be done, and to actually crack the batteries, it's going to take a lot of time and a lot of effort. The more eyes on the project, the better. Is it going to be open source? No, it cannot be an open source project for the safety reasons I mentioned earlier. I cannot give you the keys to the batteries for you to freely unlock broken batteries. It's not even a matter of liability, it's more of a matter of conscience. I don't want you to hurt yourself. So my software needs to first determine whether this battery can be unlocked or not. And if the battery is broken to the point where my software says it cannot be unlocked, and you do unlock it, it will likely just lock up again as soon as you start charging it or something like that. Or there could be a more severe problem. In either case, we don't want you to just freely unlock batteries. They're not that expensive. If the battery locks seemingly for no reason, fine. But if there was an issue, just replace the battery. Is there going to be a subscription, or is there going to be a very invasive DRM on your computer? No, of course not. We don't anticipate subscriptions, and we anticipate a fair price for the device. We do want as many beta testers as possible, so if you want to participate in beta testing, this is far into the future still. We are at infancy at the moment. I'm still even waiting for some hardware before I can start actually cracking the batteries. I haven't even started designing the interface. What you saw here, this is just like, simple tool to just communicate over I2C. So it's not even really designed for batteries per se. It's basically I2C tool. You can also do that with BQ Studio if your battery comes with a Texas Instrument chip, but it can also come with some other ones. So the tool is not a problem. The actual value is in those algorithms to solve the challenge, to unseal the battery. But in many cases, you just want to confirm whether the battery is locked or not. And I assume you would prefer to have a tool that doesn't spy on your computer and you just purchase once and you have it forever. That's my mission. All my tools come like that. Well, with the exception of some tools that require a constant maintenance, and I have to actually pay for the use of the API. Then obviously I have to pass that cost on to you as a consumer or a customer, so the project can be alive essentially, right? But tools that don't require that, and this is one of them, there's going to be a one-time fee, no subscriptions, no nothing. If you are interested in either participating in the development or participate in beta testing, either shoot me an email or hit me up on Discord or something to that effect. It's a little early, so probably don't expect anything to receive anything just yet. But once I get the software, once I get the hardware and some batteries, I'm gonna start. If you wanna support the project and you have some old batteries that are locked, discharged, and stuff like that, if you can send them to me, that'd be great. I'm gonna need as many batteries as I can have, new ones, old ones, whatever you have, for testing, right? So you can contribute that way if you just want to send some junk to my shop. If you have any ideas, definitely shoot them up. If you have the algorithms already that you either stole or acquired somewhere, maybe they fell off the truck. Of course they fell off the truck, you didn't steal them. I'm not interested. I'm doing this mainly for the fun of the challenge. This is not exactly cryptography, so it's not a very difficult challenge, but it's a challenge nevertheless. And I want to prove it to myself and prove it to you guys that all that money that you pay to people that sell you services that they don't actually provide, again, if they just found keys or algorithms that fell off the truck, they didn't really contribute much, they didn't really develop much, and they charge you a lot of money for that knowledge. I don't think that's right, and I know they are limited, because if they don't have the algorithm, there's nothing they can do with the battery. I approach it from the other side. I just have the battery and this tool over here, and I want to unseal the battery. In cybersecurity, essentially, in symmetric encryption, symmetric protection, right, where the key to encrypt and decrypt is the same, as opposed to asymmetric one, there's no such thing as it is safe or unsafe, right? We think of every such solution as unsafe, and we just focus on what is the complexity, so the work you have to put in versus the reward you get, whether it makes sense. So say in my private bay software, it uses symmetric encryption for something, doesn't matter. If you want to steal that something, you have to find the key. That key essentially needs to be in my application somehow, somewhere, right? Because otherwise the application wouldn't be able to decrypt the data. So all you have to do is find that key. Now the key is obviously not stored like you would think it would be stored. No, the key is sliced into multiple chunks. Those chunks are kept in various places, and each chunk has a modification on it. So chunk number 7 needs to be XORed. Chunk number 5 needs to be bit shifted. Chunk number 2 needs to be, multiplied by 2, that kind of stuff. So you can do that, but now consider that either you spend, it is estimated by me that you could crack that in under a year. So say it will take you a year, or you can pay $15 for the software, right? That's essentially it, right? Is the level of complexity appropriate to the value? But now if you have a software that you need to pay $2,000 a month to use, now suddenly that 1 year or maybe a few months starts looking a lot more doable. Because imagine how much money you will save if you crack that code. So obviously that would have to be asymmetric encryption, and that's how Rework Pro is protected. The license you're getting, it's an asymmetric algorithm. The key is not stored anywhere in the application. You only have public key that is used to verify checksum. But if you want to create, so the software is capable of verifying if the key is valid, but it's not capable of producing the key, because a public key is essentially a part of an actual key, right? The private key. So from the private key, you can extract public key, because it's enough information from the private key to encrypt, but not enough to decrypt. So it works in one way. It's a little cryptographic lesson for you guys. I know you haven't asked, and you probably don't care. But that's just to give you an idea how this is considered. So the security on the battery, the prevention from unsealing, it's just 2 bytes, and in response to those 2 bytes, you have to provide 2 bytes. So the question is, are you going to spend maybe a week or 2 weeks trying to crack the battery to unseal it, or are you going to spend $35 to get the new battery, and call it even $100? What do you value more, 2 weeks of your life or $100? That's why this protection of the battery is not as complex, because it doesn't have to be. It's not like when you break the algorithm on one battery, you suddenly can make millions. Well, that is something that some manufacturers or some software producers are trying to do, sure, but personally I don't think it's ethical. If that is true, actually, if someone essentially stole proprietary knowledge from some company and started their company using that proprietary knowledge to, to fill the niche on the market, resetting batteries and stuff, I don't think that's ethical. I would not do that. Plus, if that is actually revealed, you just kind of, if your company doesn't make it long term and you have to start looking for a job, no one's going to hire you, because why would they? You're just going to steal the information and start another company, right? Companies obviously don't like that, because it's an intellectual property. That's number one. And number two, it's a safety risk. That protection is there for a reason, not for you to break it, but for the battery to keep you safe, or for you to be safe from the battery. All right, at this point I'm just rambling. Drop your thoughts in the comments if you have any ideas you would like to participate, or you have some batteries that you can send, or something like that. Drop any thoughts you have. If I'm wrong about something, feel free to correct me, of course. And let's see where this project is going to take us. There's a chance that unseal feature will never work on this. We'll see. I've never tried this before, and some of my assumptions might be wrong, just like I was wrong in my previous video talking about this the very same subject. So perhaps I'm wrong in my assumptions as far as the probability, and we're not going to be able to unseal any battery. That is also possible, but in which case the tool is still going to be developed, and it'll be capable of at least analyzing the battery and telling you if it's locked or not. And if it's not locked, we're still debating on that, but probably will also include a feature to charge and discharge the battery. But we'll see about that. Thank you guys very much for watching. I do appreciate you, and I shall see you guys in the next one.